In this video, I will show you how to count in binary. And I'll also show you how to turn decimal into binary and binary into decimal. So, what is binary? Well, in our standard counting system, we have 1, 2, 3, 4, 5. Wait, I'm counting wrong. I was saying them bleh, 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 bleh. Okay, we have 10 digits. Alright? And that's why it's called decimal. That's why we count in decimal. Deci stands for 10. How about for binary? Take a guess. How many digits are there? Well, for binary, there's 2 digits. Bi. 2, right? So binary, you have 2 digits, 0 and 1. And both of these numbers, they're called a bit. Okay? And this is how computers talk. This is how computers also store numbers. So this is the language of computers. Bits, zeros and ones. So let's say we have 8 bits. Okay? So we have 8 bits. We have 0, 0, 0, 0, 8 zeros, 8 zeros, 8 zeros, 8 zeros. 8 bits right here. Okay? And these can either be 0 or 1. And currently, since everything is 0, this number will technically equal 0. Right? But I'll show you that each bit has an assigned value in binary. Now, you may see sometimes the binary numbers start with 0B, right? But that just stands for binary. If you see the B, it stands for binary. I think if you see the X, 0X, it stands for hexadecimal. But it doesn't matter. It's just some, I think VS Code uses 0B or PyCharm uses 0B when you're using Python. But that doesn't matter. Okay? Just know that binaries consist of either zeros or ones, and we have 8 zeros here, which means we have 8 bits right now. And each bit stands for a number. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, blah, 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 blah. Okay? Just as you can tell, there's the pattern here. There's a 0, 1, 2, 3, 4. The exponents just keep going up. And in doing so like this, you can count for every single number. So this stands for 2. This stands for 4, 8, 16, 32, 64. I skipped. It's 1. Sorry, it's 1, 2, 4, 8, 16, 32, 64, and 128. So each number stands for either of these. Well, how do you turn binary to decimal? Okay, let's erase some random digits. Let's do this one. Let's do this one. Do this one. 1, 1, 1, 1. Okay, so the things that are 0, ignore them. Just ignore them. We don't need them. But the things that are 1, the binary values that are 1, they're good. Okay? You use them. So we have 64 assigned with the value of 1. Therefore, we add it to whatever we have. To the other ones. 8, 1. Therefore, we add 8. 4 is a 0. We don't add 4. 2, oh, binary value is 1. So we add 2. Well, 1 is 1. So we add these numbers together. If you add these numbers together, you should get your decimal number in binary, which is, this is 72, 75. This is 75. So 0, 1, 0, 0, 1, 0, 1, 1 equals 75 in our language. Okay, let's do one more of that. Wait, actually, I can undo everything. There you go. Let's do one more of that. Let's do erase this, erase this, erase this. Okay, now we have 1, 1, 1. All right, 128. It's a 1, so we add it. 64, 0. We don't add it. 32, 0. We don't add it. 16, 0. We don't add it. Okay. This number, it's 1. Oh, this 1 stands for an 8. Oh, we add it. Okay. 4, 0. No, we don't add it. 1, this 1 in this binary number stands for 2. Okay, we add 2. So therefore, this binary number, 10001010, stands for 138 in our counting system. Now, what if you're thinking, oh, what if our number can't go up to, what if all of the numbers are 1, 1, 1, 1, 1, and we want to go to a number that's higher, right? What if we already added 128, 64, 32, dot, 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 2 plus 1, right? What if we add all the numbers? Well, computers aren't limited. They aren't only limited to 8 bits to count in. I think current computing systems, they're a 64-bit. So you can count up to 1, 2, 3, 64. There's 64 zeros, and we can store up to 2 to the power of 64 minus 1 as a number, which is an obscenely large number. Okay, well, how do you turn decimal? How do you turn decimal to binary? So our counting system to binary. How do you do that? Okay, let's pick a number. Let's pick 31. All right. Well, how do you turn 31 into binary? Look for the number that is still less than 31, but still an exponent of 2. So the greatest number that's an exponent of 2, but less than 31. So less than 31, not 32. 16. Oh yes, 16 is less than 31, and it's the greatest number that's an exponent of 2, which is 2 to the power of 4. So we set 16 equal to 1. Oh, oops, I didn't switch my eraser. 16 equal to 1. We subtract 16 from here. What do we get? We get 15. All right. Well, can we subtract 8 from 15? The next number. Oh, yes, we can. So we subtract 8 here. Subtract 8 from this, and then you get 7. Okay, can we subtract 4 from 7? Yes, we can. So it's 1. And I'm going to spoil the rest step by step, which is 0, 0, 0, 1, 1, 1, 1, 1, as this binary number is equal to 31. So if we added all the 1 values together, or the corresponding binary values together to decimal, we should get 31, which is the case. Cha-ching. Okay, let me clean this up. I'll pause the video so you guys don't have to watch. Well, how about for the number 72? Okay, what's the largest exponent of 2, but still less than 72? That's 64. So 64 is still less than 72 and is still an exponent of 2. So we set this as 1. Therefore, we subtract 64 from 72. Okay, well, if you subtract it, you get 8. Can you subtract 32 from 8? Look at the next number. Can you subtract 32 from 8? No, you can't. So you keep this as 0. Can you subtract 16 from 8? No, you can't, so you keep it as 0. Can you subtract 8 from 8? Oh, yes, you can. Oh, yes, you can. Oh, yes, you can. So you set to 1. And once you subtract 8 from here, you get 0. And you can't subtract 4, 2, or 1 from 0, so 72 in binary is 0, 1, 0, 0, 1, 0, 0, 0. All right. How about for a larger number? Larger number like 100. Let's choose 143. Okay. Which number in this binary chain, or binary number that represents a decimal number, is still less than 143, but is an exponent of 2? So the greatest exponent of 2, less than 143. Well, it's 128. Right? So we set this to 1. And we'll subtract 128 from 143. Okay? Well, once you do that, you should get 15. Yeah? Is that 15? Yes, it is. Okay. Well, can you subtract 64 from 15? No. Can you subtract 32 from 15? No. Can you subtract 62? No. So you can subtract, but you can't subtract 8. So let's subtract 8. 8 minus 15 is 7. And when we subtract anything, we turn it to 1. Okay, can you subtract 4 from 7? You can. Turns to 1. And then subtract 4. You get 3. Can you subtract 2 from 3? Yes, you can. So you get left off with 1. Can you subtract 1 from 1? Yes, you can. You get 1. Therefore, 1, 0, 0, 0, 1, 1, 1, 1, 1 is equal to 143 in decimal. So this binary number stands for 143 in decimal. And if you added all the corresponding values that are equal to 1 in binary, like so 128 plus 8 plus 4 plus 2 plus 1, and ignore 64 and 32 and 16, then you should get 143. But, as always, if you have any questions, put it down in the comment section. And if you think what I said in this video helped, I would greatly appreciate it if you subscribed and liked the video.